All right, guys, this is the last lesson of the year. This is lesson 86. We're going to finish strong. Here we go.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, lesson 86. We are going to translate sine and cosine functions. So remember, translate is just a fancy word for shifting. So we did this with our quadratic functions. We were able to shift our mother function up or down or left or right, and we were able to flip it and all that stuff. So it works the same way with these periodic functions, or in our case, our sine and cosine functions, okay? So first thing we're gonna talk about is a phase shift. A phase shift is just a horizontal shift. We use this term in the audio world a lot because when you have two microphones miking the same source, sometimes we have what's called phase cancellation. So that means there is a sine wave like this, and then there's another sine wave like this, and what happens is it cancels itself out. So we have to shift one of these sine functions a little bit to the left or right so it doesn't cancel the other wave out, okay? So a phase shift is just a horizontal translation of a periodic function. So if we have a typical function like f of x, if we add or subtract something from that x before we apply it to the sine, here's what happens. So just like in a quadratic equation, if you have something happening inside the parenthesis with x, you shift it horizontally to the opposite of this direction. So this means you're going to shift h units to the right, okay? If this was plus h, then you would shift h units to the left. So remember, it's the opposite. The vertical shifts are just how they appear. So the vertical shifts, remember, happen outside the parentheses or after you've done your whatever you were gonna do with x. So plus 2 would go up 2, minus 2 would go down 2. But in this case, since it's happening inside the parentheses, it's a horizontal shift to the opposite of what that says, okay? So let's try our first example. Here's what example 1 looks like. Y equals sine of x minus pi over 2. So in sine and cosine functions, we use radians. So for example, over here, if we say 4 units is pi over 2, so that means 8 units would be pi, and then this would be 3 pi over 2. Okay, and then we'd have a negative pi over 2, negative pi, negative 3 pi over 2. So if I drew my sine function, it would look like this. Remember, at 0 radians, sine is just 0. So, and then it finishes cycles at 2 pi. So at pi over 2, it's 1/4 of the way. Goes down. It starts to go up again there. Same thing this way. Okay. So if I were to shift this, pi over 2 radians. So remember, this needs to shift pi over 2 to the right because it's negative, okay? So my actual function of sine of x minus pi over 2, but I would have to shift everything over here. So this is what it would look like now. It would look like this. Okay, so I shifted it. See how I shifted it this much? So this is pi over 2 distance here from. Does that make sense? All right, well, let's try another one. So example 1b is y equals cosine of x minus negative pi. I don't know why they do this. That's just x plus pi, right? So that means we're going to shift pi units to the left, okay? So if this is our grid, we have negative, we'll use the same grid we did last time, and this is pi over 2. So this means this is pi. This means this is negative pi, and then negative 3 pi over 2, and then positive 3 pi over 2. Normally our mother cosine function starts with 1 at 0 radians. So this is what our normal cosine function looks like that. So what we're gonna do is we're gonna shift that cosine function pi units to the left. So pi units is right here. So this guy is gonna go right there. So this is where we're gonna start this. And it's gonna go down. This is gonna go like this. Oh my gosh, I'm so good at this. All right, so that blue function is the solution to example 1b. That's pretty. All right, well, let's try our vertical shifts. Okay, these are our vertical shifts. So this is 2a. This is what 2a says. Y equals sine of x, just x. You're not x minus anything. And then you're adding 2 after the sine of x, okay? So this is after taking the sine of x, you're adding 2. So this is a vertical shift. So we're going to shift up 2 units, okay? So what does our normal sine function look like? Well, remember, it looks like this. If this is our pi over 2, pi, negative pi over 2, negative pi. So our normal sine function looks like this, right? Okay, so our shift is going to be this same thing, but up 2 units. So if this is 1 and this is 2 units, we're gonna just take this guy and we're gonna put it up there. So this is what this one looks like. So this is gonna go like this. You can make those sound effects if you want. It's actually pretty helpful. Okay, there it is. That's easy. That's a vertical shift. Let's try 2b. Or not to me. Or not to me. What? I didn't say that. Y equals cosine of x minus 1. So you're going to take your cosine function and you're just going to shift it down 1 unit. So you're going to shift down 1 unit. Okay? So your typical cosine function, let's see here, here's down 1 unit, starts with 1 right there, so it's going to look like this. Okay, so see how we shifted down 1 unit. So our normal cosine function, remember, starts right here. So this is your mother cosine function. So we just shifted down 1, okay? So if I, just so you can kind of get a visual here, cosine of x. So we just shifted down 1, all right? Okay, so example 3 combines them together. This is really exciting. This is really exciting. So here's example 3. Let's try to graph y equals sine of x plus pi, so horizontal shift, plus 2. So let's see, our h equals pi, or actually negative pi because it's opposite of that. And then our vertical shift, which is what we call k, is going to be just positive 2, okay? So we're gonna shift left pi up 2, okay? So let's draw our sine function. Our sine function looks like this. Okay, this is our normal sine function. So we are gonna graph this guy. So we're gonna go left pi. So we're gonna go left pi. So if this is pi over 2, remember, this is pi. So we're gonna take this and we're gonna shift that to right there. And we're gonna go up 2. So we're gonna take this guy and go up 2. So if this is 1, this is 2, it's gonna go right there. So if you follow the mapping here, this is what this looks like. So I'm gonna just take this and shift it left pi and up 2. So here's what that looks like. And then that's cool. So does that make sense? That's pretty cool. So this guy, this little thing got shifted to the left and then up right there. That's awesome. All right, so let's put all this together. So these are our sine and cosine functions in standard form, okay? Y equals maybe something times sine of maybe b times something of, and then x maybe subtracting something plus maybe adding something. Okay, so remember that h is your horizontal shift, that k is your vertical shift, and then remember a, we talked about this a few chapters back, a, or the absolute value of a, is your amplitude. Remember, that's how tall your function is. And then your b helps you determine your cycle length or your period. Okay, this works the same way with cosine functions. So a times cosine of something times x minus h plus k. All right, so this is a lot of letters. Let's try an example and see if we can make sense of this. So this is example 4, and I'm gonna graph y equals 3 times the cosine of 2 times x minus pi all plus 1. Okay, that's a lot of numbers. But we know how to do this. This is in standard form. So we know what the amplitude is. We know what our shift is, our horizontal shift and our vertical shift. And then we know how to determine the length of the cycle or the period. Let's forget the shift right now. Forget the shift, and let's just graph the normal standard simpler function. So this is a simpler without the shifting. Is that a word? Simpler? Sounds right. Cosine of 2x. Okay? Well, how do you graph that? Well, cosine, remember, starts at 1. So if this is 1 here. But since the amplitude is 3, it's going to go up to 3. So if this is 2 and this is 3, this is what our amplitude looks like, okay? So it's going to start here, and then if this was pi over 2, and this was pi, this is 3 pi over 2. Okay? So let's see what this 2 means, that our period length, our period is just 2 pi over 2, which is just pi. So it's going to finish its cycle before it gets to pi. All right, so let's see if we can draw this. So it's got to go down and back up. Okay, so it's got to go all the way down to -3 as well. So this goes all the way down to here and then back up. Okay, not bad at all. So negative pi over 2 over here. So it kind of looks like that. Okay, I gave up at the last minute, sorry. All right, so what does it mean to shift? Well, this is going to be, we're going to shift right pi and up 1. Okay? So we're going to take, this is going to go over to pi here, which if you do that, look what happens. You're going to put this and that there, so it's going to look the same. So really, this shift doesn't, it kind of cancels out. So if you shift, see how if you shift everything to the right, it's just going to end up right on top of the next cycle. So you don't really have to worry about shifting to the right, but we do have to shift it up 1, okay? So we're going to take this and we're just going to go up to our next one, which is 4, and we're going to shift it up 1. All right, so this is going to look, this is going to be a little sketchy here. Oh, not good, not good. I'm losing it. I'm losing it. I'm losing it. All right, well, you get the idea. Anyway, that shifts up. Let's go to our graphing calculator. This will be much more pleasant. Okay, go back to our GeoGebra. So there's our y equals sine of x. Nice, nice. So let's just do y equals 3 times the cosine of 2x. Okay, so there's where that's what our function looks like. Nice, pretty. So let's just type our shifted function, y equals 3 times the cosine of parenthesis 2 times another parenthesis x minus pi, alt p. And then on the outside of these parentheses, I'm going to say plus 1. Oop, not 21, plus 1. So see what's happening? So you can see that, remember, it shifted one whole cycle. So it shifted pi to the right, so it landed on top of itself, but then it shifted up 1, okay? So that's pretty cool. Let's try another one. And we're just going to try this one just on our graph here. So we're going to plug it in nicely. So here's what example 5 looks like. I'm going to graph y equals negative 2 times the sine of parenthesis 1/2 times x plus pi minus 1. So let's analyze this. Okay, so first of all, the negative means it's going to flip over. That's what negatives do. They just flip everything over. The 2 is the amplitude. That means it's going to go up 2 and down 2. Okay, and then that 1/2 means the cycle is going to be 2 pi divided by 1/2. So it's going to be 4 pi. So that means it's going to be fat. All right, remember that fraction makes it fatter. Fraction, fat fraction. Okay, and then it's going to shift left pi because of that. It's plus pi, so it's going to shift the opposite of that, left pi, and then it's going to shift down 1. All right, so let's write all that out so we can analyze it, but we're going to let this graphing calculator do the work for us. So our amplitude equals the absolute value of negative 2, so our amplitude is 2. All right, our period is 2 pi over 1/2. Well, 2 pi divided by 1/2 is just 4 pi. Okay, so it's going to have to go 4 pi. All right, and then it's going to shift left pi and then down 1. Okay, so first of all, let me get rid of these. Let's write our normal simplified function. So we're going to say y equals negative 2 times the sine of 1/2 x. Okay, so that's what this guy looks like. See how it takes 4 pi to get there. So what is our shifted function going to look like? Well, let's take a look. Let's just write it out. Y equals negative 2 times the sine of parenthesis 1/2 and then another parenthesis x plus pi, and then all that minus 1. Okay, All right, so I'm gonna zoom up here. Okay, so let's look at our orange function first. So see how that sine function normally goes up and to the right, but since we flipped it, it's negative. Now it's just the reverse of that, okay? And then -2 means the amplitude is 2. See how it goes up to 2 and then down to 2, and then it's 1/2 pi, or 1/2 x, so that means our cycle was 2 pi divided by 1/2, so it goes all the way to 4 pi. Remember, 4 pi is like 4 times 3.14, which is 12.56. So what happens, see how it completes the cycle right at about 12.56. See that right there? Okay. So if I add my shift, I'm shifting to the left pi. So basically look at the purple function now. See how it shifted left pi. So a -3.14-ish. All right. And then it shifted down 1 unit. So if this is 5 units here, this is 2 units. It's going to go down 1 unit. So it makes sense. That's pretty cool. All right, that's it for lesson 86, and really that's it for Algebra 2 this year. Good job, guys. We're gonna do one more test review, but other than that, awesome. Way to finish strong. I know it's been a crazy year, but you did it. I'm proud of all of you. Okay, I don't wanna get emotional. All right, see you in our test review.
Flack math! Give me some math and I'll give you some flack. Flack math!